Alright, let's get to our question. Our question states that we have a hammer that taps the end of a 4-meter long metal bar at room temperature, and a microphone at the end of the bar picks up 2 pulses of sound, one that travels through the metal and one that travels through the air. And it says the pulses are separated in time by 9 milliseconds, and what's the speed of the sound in this metal? So I have this little diagram right here, and it shows you the hammer hitting the metal bar, and this is just to show you that the sound in the air hits the microphone first, then there's like 9 milliseconds of nothing, and then finally the sound in the metal hits the mic. So the process is we're going to use the velocity of air to find the time that the wave in the air hit the mic, and then we're going to subtract 9 milliseconds by that time to find the time that the wave in the metal hit the mic. And then finally, now that we have that t from part 2, we can plug that into the velocity equation to find the velocity of the sound in the metal. So for our first step, we don't have the velocity of air, but if you Google search the velocity of air at room temperature, which is stated in the question, it is 343 meters per second. And we could plug that velocity into this equation to find our t, which is the time that the air hit the mic. So you just manipulate these variables to get this equation right here, which is the time that the air hit the mic equals the distance between the hammer and the mic over the velocity of the air. And when you plug it in, you have 4 meters, which is the distance between them, over 343 meters per second, which is 0.012 seconds. So now that we have that, we know that the time between the air hitting the mic and the metal hitting the mic is this t right here, which is t air minus t metal, which is 9 milliseconds. But we're trying to find t metal because we don't know t metal. So we can manipulate this equation right here to get the time of the metal equals the time of the air minus the time that the time between both of them hitting the mic. So when we plug that in, we have the time of the air, which is the number we got from the last step, minus 0.009 seconds, which is just the translated version of milliseconds to seconds right here, and we get the time that the metal hits the mic is 0.0027 seconds. So now that we have that, we can plug this t into this equation to find the velocity in the metal. So we plugged it in right here, and we have 4 meters over 0.0027 seconds, and that gives us 1,481 meters per second, which is the velocity that the sound wave in the metal is. And that's our answer. So there you go.